Okay, so we're going to take a quick minute and look at, just review something real fast so that it'll lead us into the next thing. And so I want to remind you what a perfect root is. And we're just going to write this in our composition book on page 7. So you're not going to have a handout for this paper. This is just some quick notes. Don't write big because I'm going to not write a lot, but if you write really big, it's not going to all fit. So just some examples of some perfect roots. The square root of 9, because I can simplify that without having to do anything weird to it. I can just take the square root of 9, and that gives me 3. Another perfect root would be the cube root of 8, because if I take the cube root of 8, it's just 2. Or if I take the fourth root of 625, that means what multiplies by itself 4 times to give me 625, and that would be, I'm sorry, I almost wrote the wrong thing, that would be 5. Those are examples of perfect roots because when I simplify that radical, the radical goes away and I'm just left with a whole number. And so we do that, or we did that before, just with square roots when we rationalize denominators. So I want to remind you about rationalizing the denominator. And we did that, and this is really, it's stuff that we've already done, and so it shouldn't be anything that's super complicated for you. But remember back when you would do something like this and you had to simplify an expression like the square root of 5 over the square root of 2, and we just don't leave radicals in the denominator. So we would get rid of that radical by multiplying it by just the denominator. And the reason we did that is if I multiply the square root of 2 times the square root of 2, I get the square root of 4. On the top, we would do the square root of 5 times the square root of 2 and get the square root of 10. But what was special about that is the square root of 4 is a perfect square, and I could simplify that and get the square root of 10 over 2. So I got rid of the radical in the denominator. And so you already know how to do it with square roots. I'm going to show you how to do it with not square roots. But first of all, I want you to just get some practice at creating that perfect root, whatever the index may be. So here's what we want to get to. I want to be able to do this. I want to take, for instance, the square root of 3, the cube root of 3 over the cube root of 2, and rationalize that denominator so that when I simplify, I don't have a radical in my denominator anymore. So I've got to multiply by the cube root of something to give me a perfect cube over here so that when I simplify it, I don't have a radical anymore. So I got to multiply by something right here to give me a perfect cube here. A perfect cube, because I'm taking the cube root. So that when I simplify over here, if you do it correctly, and you're going to, really what you're going to end up with is whatever this number is, you're going to end up with that number. It's magic. So here's what I want us to practice first, is knowing what you've got to multiply here to get that perfect root, whatever it is that you need here. So this is what we're going to do real quick. We're going to create, a perfect nth root. In other words, it can be a square root, a cube root, a fourth root, a fifth root, whatever. And so it's just knowing what you have to multiply by to get what you need to be able to simplify it. So I'm just going to do a few. And what I want you to do real quick is grab this little graphic organizer that I gave you with, and a few of you I've already talked to about, change that word exponent to index because these are going to be the index on my radical. This is going to be the number that I'm raising to a certain power. This is going to be my base. You'll see what I'm talking about. So if I have the fourth root of 8, So this is how this works, and some of you aren't going to need this, but here's the basis for it. If my index is 4, if the number in the radical is not in that column where I'm taking the 4th root, then somewhere in that column there's a multiple of 8. 16 is a multiple of 8. See it right here? If I do 8 times some number, I'm going to get 16. And if I can get 16 in my 4 column, I can take the 4th root. So what times 8 will give me 16? The answer is 2. So the 4th root of 16 is, I told you a lie a minute ago, I apologize, I didn't do it on purpose. It's not going to necessarily always be this number. That one just happened to retract that statement, scratch that out. Sorry about that. My mouth outran my brain. So if I'm taking the 4th root of 16, my answer is 2. And my goal is to get rid of the radical. So let's do another one. If I take the 5th root of 64, so I'm going to go into my index of 5, and 64 is not in that column. But if you will look back over here and find 64 right here, see that 64 will turn into a 1024 if I multiply it by something. And there are so many ways that you could find what you need to multiply by. The easiest way that popped right into my head just now would be to divide this by this. And 1024 divided by 64 is 16. So I would multiply this by the 5th root of 16. If you don't believe me, let me show you. I would take 1024 divided by 64, and I got 16. So that's what I've got to multiply by to get the 5th root of 1024. The 5th root of 1024 is 4. So I can simplify that to a whole number and get rid of the radical. If you're still not an expert, it's okay. We've only done 2 examples. If I take the cube root of 81, my index is 3. So in that column where my index is 3, I do not see 81. It's not there. But if I look, 81 is here. So that means that there is something that I can multiply 81 by to get 729. So if I do 729 divided by 81, I get 9. So I'm going to multiply this by the cube root of 9. When I multiply by the cube root of 9, I get the cube root of 729. And the cube root of 729 is 9. So I've simplified that radical into a whole number. I've manipulated that into this so I can get this. Let's do a couple more. If I have the 6th root of 16, I'm going to throw some variables in here now. I got to multiply this by something to get something that I can take the 6th root of so that I can get a whole number. So I'm going to go to my index of 6, and 16 is not there. But 16 will go into 64. So if I do 64 divided by 16, I get 4. So if I multiply by the 6th root of 4, but I also need my variable to have an exponent or 6 or some multiple of 6. So if I've got 4 x's here, I need 2 more to give me a total of 6. X to the 4th and x squared gives me x to the 6th. 16 times 64 16 times 4 gives me 64, and I can take the 6th root of 64. And the 6th root of 64 is 2. So my answer is 2, and the 6th root of x to the 6th is x. The 4th root of 3x, I need to multiply by something to give me a perfect 4th root so that I can simplify it and not have a radical. So if I go to my index of 4, 3 is not in that column because I'm doing, I have a lot of room up here, but I'm trying to find the 4th root of 3x and I can't. So let's change that so that it is something raised to the 4th power. So the 4th root of 3 is not here, but 3 will go into 81. You find a multiple of this number in your index column. So what's 81 divided by 3? 27. So I'm going to multiply this by the 4th root of 27, and I only have one x, and I need a total of 4. So I need to multiply by x cubed. 1 plus 3 gives me 4. 27 times 3 gives me 81. And the 4th root of 81 is 3. And the 4th root of x to the 4th is x. This is the last one I'm going to do in the book. That is the cube root of 7x squared y. I've got to multiply by something to give me a perfect cube under my radical so that I can simplify, take the cube root, and get a whole number answer. So index is 3. I'm taking the cube root. 7 is not in that column anywhere, but 343 is a multiple of 7. So I'm going to figure out what I need to multiply by taking the 343 divided by 7, and I get 49. So I have to multiply this by the cube root of 49. I've got an x squared, and I need an x cubed. So that means I need one more x here. I've got a y squared, and I need a y cubed, so I need 2 more y's here. 7 times 49 gives me 343. The cube root of 343 is 7. The cube root of x cubed is x. The cube root of y cubed is y. So you're going to do a little practice sheet where you practice finding that perfect nth root. This is your row of indexes. These are going to be your bases. This is what it's going to end up being when you take that root over here on the end.